should have just said.
Okay, thank you. All right, so we are going to learn about complex numbers. Don't worry, they're not too complicated. It's just the way they are defined. So everything that you've basically learned in math has all been with real numbers. How do we know if it's a real number? It's something that you can locate on a number line. So if I said 10, can you picture you have a number line in front of you. Can you figure out where 10 is on the number line?
Yeah.
What about pi?
Yeah.
Well, you can approximate it. It's
3.14.
3.14, so it's going to go just a little past 3, right? What about square root of 80? Could you find an approximation and figure out? Yeah. So imaginary numbers are not numbers that you can find on a real number line. Remember when you would get to something like square root of negative 4 and we would say, oh, that's no solution, right? Now it has a solution. I know.
Wait, could you say that again?
So square root of negative 4, we used to say that's no solution. Really, we would say there's no real solution.
Isn't that a decimal?
So if you were to plug in square root of negative 4 in your calculator, it would get an error because your calculator is operating with real number systems. Okay, so why do we have these imaginary numbers? Oh, because they're just fun. No, they actually have real world application. They're used in electricity and electrical engineering. So it will show you like describing electrical currents going in and out. So we use imaginary numbers to show that. Also, it's used in physics. Again, stuff that you aren't at yet, right? But they are applicable, okay? So in Algebra 2, we're just gonna learn the basics, okay? What is the imaginary unit I? That's the square root of negative 1, okay? So any guesses what square root of negative 4 would be?
4i.
Well, what's square root of 4?
2i. So negative
2. So this would be 2i.
There is no square root.
What happens to the negative?
So it is expressed anytime you see the square root of a negative number, that means there's going to be an I in your answer.
Okay.
Okay? So anytime you have the square root of a negative number, that's an imaginary unit. Okay. So here's some examples. 5i. You can have a fraction, negative 2/3. You can have a negative in front. You can have I times the square root of 3. I is not a variable, okay? It's, again, I stands for imaginary unit. So let's look at,
So I is not a variable.
right, so what you want to think about, I can think of this in terms of separating square root of negative 9. I'm not going to write this out all the time. I want you to jump right to the conclusion. Would you agree to square root of negative 1 times square root of 9 would give us the square root of negative 9? Yeah. I just told you that this square root of negative 1 was I. What's the square root of 9?
3i.
So it would be 3i.
Where's the square root of 125?
We're going to have to simplify that. So basically take the square root and we're just going to tack on the end the I. So what would square root of...
8i, right?
This will be 8i. Okay, now square root of 18. So pretend, let's not, kind of ignore the negative for the moment. Think, how can I simplify square root of 18? So I could either do a factor tree or, right, I could do 9 and 2 and 3 and 3. So remember, the pair of numbers comes outside the square root. Yeah, so this would be 3 root 2. Now, how would I...
3 root 2i.
Okay, I'm going to put the I in front of the radical, like here, just so I don't accidentally put it underneath. So I'm going to write it as 3i root 2. Okay, so how about square root of 125?
5i root 5.
Yeah, so square root of 125, if we break that down, it would be 25 times 5. And so I have a pair of 5s with a 5 left over. So remember, the square root of 25, that's going to be 5i with a root 5. Okay, any questions so far? Okay. All right, I'm just going to erase this part here so I...
Do we have to curve the I?
No. I have a habit of I don't normally when I write curve the I. I also don't curve the T, but I always do that so I don't mix it up with the plus sign.
Oh, yeah.
You know what I mean?
Yeah.
It's really annoying when T shows up as a variable, but you have to deal with it, so that's why I put the curve. Okay, let's look at some patterns with powers of I. So we'll say I to the first is I. Okay, again, what's I?
I.
It's square root of -1. Why do you think I squared gives us -1 then?
Oh, because square. The
-1
square
times
of.
-1 is 1. Oh.
Right, so if I took the square root of -1 and I square it, don't I just get back what's underneath the radical?
Oh, yeah.
Okay.
So this will be positive.
So what do you, so I squared,
They're all -1.
so here's what we need to remember. We need to remember I squared is -1. I, there's nothing we can do to simplify it. What do you think I cubed?
1, positive 1.
Positive 1? Any other guesses? -1 squared?
Negative
think
1
it's one.
times root of negative 1.
I
Okay,
think it's 1.
if I had x to the third power, could I rewrite that as x to the first times x to the second?
Yes.
Yeah, because of the property of adding exponents. Go ahead and try that with I to the third. That's going to be I to the first times I squared. Well, I can't do anything with I to the first,
So -1i.
but I squared is,
I times I.
so that would be negative. So it's I times -1.
-1.
So I to the third
Is negative.
is the same thing as -I. Right? Because if I broke this up, right, I squared we already said was -1. So -1 times I is just -I.
So this is positive I.
Okay, let's see. What do you think? How could we rewrite I to the fourth power?
I squared times I squared.
I squared times I squared. Now go back here. What was I squared equal to?
So it is just -1.
No, this is positive. It's positive 1.
Is it positive or negative?
Oh, because
That's positive.
Positive.
Yeah, so if I have a -1 times -1, I get a positive 1.
So is it just I?
So let's take a look at the pattern. It was I to the first. I squared becomes -1. I to the third becomes -1. I to the fourth
Positive 1.
is positive 1. Now watch the pattern. What do you think I to the fifth is going to be?
I squared. Negative I
Negative.
squared.
Oh, hold on. How can I rewrite I to the
So is
fifth?
it I to the 4th times I.
How about that? Why did I rewrite it with an I to the fourth power?
Because we know I fourth equals 1.
Because I to the fourth is equal to 1.
Positive.
So I get positive
Alright.
I. That's a bad.
the same thing. It's going to be -1.
So 2.
Oh, look at that. So I to the first was 1I, and I to the fifth was 1I.
So these are all going to line up.
They're all going to line up. Let's see. How could we rewrite I to the sixth power?
-1.
How about I to the fourth times I squared? Why would I rewrite it that way?
Because that's -1 times 1.
Negative.
-1.
There we go. So I to the sixth is -1. Okay, how would I rewrite I to the seventh?
Negative I.
Good. I to the fourth
And then 8.
times I cubed. And we already established, so notice I'm always going back to this I to the fourth power. So this gives us,
With I negative.
what's that, Gabe?
I don't get it.
Okay, I'm going to show you the pattern in a minute. You see I to the third. Did you understand how that came out to negative I?
No.
Okay. If you go back to what your exponents mean, let me just find it.
Is it by 4?
It's by 4.
By 4.
It is by 4. Hold on. What was that one? I to the third? Okay. Remember,
I-12 is positive I also.
that's really what I to the third means.
I-12.
It's square root of negative 1 times square root of negative 1 times square root of negative 1. What are these two multiplied together?
-1.
Negative 1. And what did I say square root of negative 1? That's our imaginary unit. So it's negative 1 times I, which gives us negative I. So anytime I have I to the third, I know that's the same as negative I. Now, look at I to the 7th. Remember my rule for exponents. I can rewrite a 7th power as I to the 4th times I to the 3rd. Why would I do that? What did we say I to the 4th was equal to? 1. And what's I to the 3rd equal to?
Negative I.
So my answer just has to be negative I. Okay, just bear with me. We're going to keep going, and I think some of us already saw the pattern.
Why
Yeah.
are some of them 1 and some of them I?
Okay, I want you to look at the pattern. Goes I, negative 1, negative I, 1. I, negative 1, negative I. Why is that going to be 1?
Because the pattern says so.
Because the pattern says so. Also, could I write I to the 8th as I to the 4th times I to the 4th?
Yeah.
And we already said I to the 4th was 1.
Is that I to the -1?
No, it's just 4 plus 4 gives us 8. Okay, just bear with me, you'll see it. What's I to the 9th going to be?
I.
And I to the 10th is?
-1.
And then negative I, and then 1. What do we notice about I to the 1st, I to the 5th, I to the 9th? How are we increasing?
4.
By 4. I squared, I to the 6th, I to the 10th,
Oh, increased by 4.
increased by 4. To the 3rd, to the 7th, to the 11th.
So all even numbers are 1 and all odd numbers are I?
Well, what about these numbers? These were all negative 1.
Yeah, I mean like 1 and all the odd numbers are I. With some of the
Oh,
numbers-
I see what you're saying. Okay, so
Yeah.
Zach says anything that has an even exponent is either going to result in 1 or negative 1.
Yeah.
And anything with an odd exponent is going to result in I or a negative I. Good observation.
Are
Vita?
prime numbers going to be just negative I?
Not. Well, let's think about I to the 13th. Where would I to the 13th fall?
I.
And 13. So, any other observations? Kate?
That's no question. Does this pattern go on forever?
It goes on forever. What do we notice about the 4th powers? The 4th, the 8th, the 12th? What do you think the 16th would be?
1.
And the 20th would be?
1.
I to the 80th.
1.
1.
So anything that is divisible by 4. So if the exponent is divisible by 4, it's always going to equal 1. Make sense? Okay. So really, this comes down to remainders. Let me explain. If you divide 5 by 4, what's your remainder? 1. So it's I to the 1st power. If I took 6 divided by 4, what's my remainder? 2. So I squared. It's divided by 4. If I divide 7 by 4, what's my remainder? 3. I to the 3rd is negative 1.
Oh, okay.
Okay.
So if the exponent is divisible by 4,
Yeah.
the answer is 1.
So let's look at what I mean by this. The 53rd. I don't want to have to keep doing this table, but let's divide 4 into 53.
You do it.
It's 4.
Okay, I know,
13,
but
remainder
I want to
one.
come up with a remainder, so let's see. I know.
It's remainder
Old fashioned, long division here. All right, bring down the 3. 4 goes into 13. 3 times.
one. This remainder one.
Okay, that's my remainder.
Not even this one.
So that means that's the exponent that I need. So this is going to be equal to I to the first power, which is just I. So I to the 53rd power is the same as I. What I basically want you to end up with is one of these answers. It's got to be I, -1, -I, or 1. What about 115? If we divide that by, sorry, I didn't give you guys a lot of room here. If I divide that by 4,
Negative I.
okay, Jacob says -I. What do we think? So I got 28 with 28 or 29?
20.
I got 28, but my remainder is 3. So that means this is equivalent to I to the 3rd, which is -I. So Jacob was right. Sorry. Okay. I to the 74th. What do you think? Now, some of you might be able to do this in your head, right? 4 goes into 72 evenly, right?
Yes.
And so that's the way I look at it. I don't bother with, if you could do quick mental math, like I know 4 goes into 72, and then you'd have 2 more. So it's I squared, which is -1. Or do the division, and the remainder is always going to be your exponent. Okay. So if I gave you like a really big number, like 1,037, could you figure out which one of these it would be?
1.
Without a calculator,
1.
right? Because 1,036 is divisible by 4, so it would be I to the first. Okay, if it's a little confusing, so yeah. Okay,
So we have to do like the old fashioned math for it?
old-fashioned long division. But you're only dividing by 4. It's not like you're dividing by 173, right? You're just dividing by 4. You good, Lily? Okay. All right, let's look at some simplifying, and then we'll do square root property. I know. Very exciting. Okay.
Are we having a worksheet for this?
Oh. I have a worksheet for, I think, 4.7. Okay, 3i times 4i.
What?
Okay, here's what we're going to do. We're going to multiply the 3 to the 4, which is 12. And what's I times I? Right? So 12i squared, but then I want to go back to, I never want to have an exponent for I.
144i.
So what's I squared equal to? -1. So I want to replace the I squared with a -1 to make that -12. Okay.
But what if you get like in that situation something that's not equal to -1 or 1, so you get like
That's okay. You can have I in your answer. Yeah. Yeah, if I had like times another 2i, I would have I in my answer. Yeah. It depends. I'll give you a hint. And it has to do with Zach, what he said. How many, if you have an even power, you're going to get 1 or -1. If you have an odd power, you're going to end up with I in your answer. How many I's do we have here? 2. We have an even number of them. So I know I shouldn't have I in my answer. Okay. Now on the previous page, we did each of these. So let's simplify. What's the square root of 12 going to be? 4 and 3. So how would I write that? I would write it as 2i root 3. and then I would multiply it by I. So anytime I have a negative, I'm going to bring an I outside.
Yes.
Are we good? What happened?
Even numbers have I in it.
No, even numbers have 1 or -1 in it.
Oh.
So should this one have an I in the answer? How many do I have? I have 2 of them. I have an even number, so I shouldn't have an I left over. What happens when I multiply these two? I get 2I squared, and square root of 3 times square root of 2 is square root of 6. I just don't want to leave the I squared.
What would the square root of -6?
Okay,
Oh, you put the I.
yeah, pull the I out in front, okay? You want to make sure, don't multiply these together and make that the square root of positive 24. This is an imaginary number, this is an imaginary number. Okay, what's I squared going to be?
-1.
Okay, so what would be my final answer?
-2 times square root of 6.
Yeah.
Wait, what?
Because anytime you see I squared, you're just going to think that's a -1. So that just makes that a -2.
Okay.
All right. Good? Okay. Last thing. Root 3 times root 2.
So it'd be 2I.
Oh, actually, it's not the, sorry, it's not,
-2 root 6. Is the you're okay.
I'm jumping ahead. It's not the last thing yet. But, okay, square root property. When we solved these previously, we did factoring. We put everything on one side, factor it. But you should have learned this idea back in Algebra 1, taking the square root of both sides. And don't forget, we always get plus or minus when we're solving, right? So we take the square root of both sides and plus or minus. So let's take a look at this one. I said by factoring or by square root property. I want to practice square root property. First thing we want to do, let's divide both sides by 4. So we get what? X squared equals -25. Okay, now I want to take the square. The only way to get rid of a square is to take the square root. So I get x equals, now, again, up until now we would have said, oh, that's no solution. But now I got these imaginary numbers to help us out. So, okay, so plus or minus I times 5, or we'll just write it as 5I. Don't forget the plus or minus. Well, if I do -5I times -5I,
Oh, it'll still be 25.
it'll be 25I squared, which gives us, it'll still be -25,
Oh. Okay.
right? Do you want me to see it? Do you need to see that?
Well,
No, I
-5 times -5 is negative. It's
Yeah.
positive
Well,
25.
I times I is I squared, and I squared is negative.
Yeah, so if I do 5I times 5I, this would be 25I squared. Isn't that -25? And if I have
putting the
negative,
I in it. Okay.
would -5I also be an answer?
Yeah, I mean,
Yeah.
25, I think.
Yeah, so I get -25. So this is kind of the check, if you wanted to do it.
Okay.
Okay, let's subtract 20. And then we'll divide both sides by. Okay, so what do we get here? X squared equals -4?
Yeah.
And then when I take the square root, okay, don't forget the plus or minus. Square root of -4 will give us
Plus or minus 2I.
plus or minus 2I. Okay. Are we okay? Questions? You okay? Which part is confusing?
Just remembering what I moved. Like the,
I is just remember I is anytime you have a square root of a negative.
no, I'm saying like, if it's like an I to like the 6, like,
Oh, those previous ones? Don't
can we only,
I can review that. More of the focus is going to be on this kind of stuff though. You have very little of the I to the 6th power or something. Okay. Usually you just have to deal with I and I squared. All right. Now, we are going to look at complex numbers. Basically, a complex number just has a real number. So A is the real part and BI is the imaginary part. They're not like terms. So we kind of treat I like a variable here. So when I'm simplifying, I can only combine the 3 and the 4.
You can't FOIL.
This is a plus.
Oh.
We'll do FOIL here.
Oh.
We will do FOIL. So here we're just kind of, right, we're combining 3 and 4,
Yeah.
and then 5i and a minus 3i.
So 7 plus 2i.
Good.
Is that it?
That's it. That's not so bad. What's the next one? I'm just subtracting, so just remember. So it's going to be, okay, 3.
Minus 7.
Minus 7. 7.
Minus is
Wait. It's minus negative 2i.
The opposite, so it's 2 plus.
Minus-
3
Minus 3i.
Yeah, minus 3i. Did somebody say that? Sorry. Okay. Good so far? This isn't bad. This is pretty easy. Next one. What do we want to do here? We're going to distribute. So I'm going to get 6i minus 15i squared. I want to rewrite this always in this form. Okay? My answer should always be written A plus BI. What's 15? What's this going to give us here? Minus 15i squared?
15.
15 is plus 6i. 16
6
plus
I
15.
plus 15.
Just plus 15?
Yes.
So I'm going to just switch this around. There's a reason we write it this way. Later in pre-calculus, you will graph complex numbers.
Oh.
Don't worry. It's really simple. It's like you treat this as your x coordinate, this is your y coordinate. So I want you to get in the habit of putting the real part first and then the imaginary.
I think I might just take statistics instead.
Pre-calculus is great, though. You got to take pre-calc next year. No, it's not. No, it's not. Okay, FOIL. What do we have? Okay, so 5 times 3, 15, minus 5i, good, minus 6i, plus 2i squared. Okay, now I just want to clean that all up. Remember what I said, I don't want to have any powers of I in my answer. So
So
I have,
minus 2.
good. So I can combine the middle, and that plus 2i squared will become a minus 2. And then how am I going to write the final answer?
15 minus 11, 9.
Good. All right. Questions? I think it's just these last 4, right? Yeah. Okay. Did I go too fast? I'm sorry, Lily. Here you go. Here. No. That's my. If I go too fast, let me know.
Do you still need this?
Okay, dividing complex numbers. Okay, back in Algebra 1 or geometry, do you remember like special right triangles and sometimes all that stuff? What did we do when we had a radical in the denominator?
Have
We
to
multiply
multiply
it.
it.
Okay, what did we multiply
We
by?
multiply by the bottom.
We had to multiply by root 3 over root 3. Why? Because,
You need it out of the
Yeah.
denominator.
okay, because we didn't want to have,
That would be 3, not 9.
oh, thank you. It's going too fast. We don't want to have a square root in the bottom. What is I? I is the square root of negative 1. So we treat it the same way. We don't want to have an I in the denominator. So no I's in the denominator. Right, so what would we multiply by? I over I. Whatever we multiply the numerator, we're going to multiply by the denominator. So in the numerator, we get 2i. We got I squared, which is negative 1. So I get Just negative 2i, right? Because if I have 2i divided by negative 1, we just put the negative out in front. Okay. All right. Again, make sure your answer is always in a plus bi. Okay, next what we're going to do you remember multiplying by conjugates when we had radicals? Conjugate? Here, no, not something we remember? So if you have something like this, you can't have that square root in the denominator. So what we would do is we would multiply by what's called the conjugate, which is just changing the sign. Does this look at all familiar? It's usually something you learn in Algebra 1, but it's been a long time. So why does that help get rid of the radical in the bottom?
Doesn't it cancel them?
Wait, where did you get those numbers from?
This is just a random example. What happens in the denominator?
It cancels out.
Yeah, what would happen? What's square root of 3 times square root of 3?
Oh, you would FOIL that.
We'd get 3. And then what happens when I do the outside and the inside? They
You can't just
cancel.
multiply by negative I for that one?
No, we have to do the conjugate. So did we get rid of the square root in the bottom?
Yeah.
Good. So instead, I'm not just going to multiply by I, I'm going to multiply by 2 plus I.
Wait, would it be the same if there's like a plus? You do it by
Yeah, but we just changed the sign. Yeah. So if it's plus, we make it minus. If it's minus, we make it plus. These are conjugates. Okay, what happens in the numerator? We get 6 plus 3i, 4 minus I squared. Remember, when these are opposites of each other, it's just the first and the last. You don't have to worry about the outside and the inside because they'll always cancel.
Oh, so we actually have to FOIL this.
Yeah, but wait, watch what happens. I have 6 plus 3i in the numerator. I'm going to get 5 in the denominator, right? Because that's going to be 4 plus 1. So I'm just going to rewrite it. I know it seems like an unnecessary step, but again, we want to write it so it's separate. So we have a real number and then our imaginary number separate. That's our answer.
But like technically, like the first thing we did is right. Because 6 plus
Yeah.
3i.
It's all in the correct order. Oh, right.
I'm saying like the 6 plus 3i over 5.
Yeah.
That's like correct, right? Like we just leave it like that.
But is it in the form?
Like it's correct, right?
This is correct. Just make sure to write it as that. I'll remind you when we have the test. What would you multiply this next one by?
3 minus 5.
Okay, so 3, oops, I didn't mean to put my times. 3 minus, okay, so on the top we'll distribute, so that will give us negative 6i plus 10i squared, right? Okay, in the bottom we just have to do the 3 times, so 9 minus 25i squared.
Oh, wait, no, because that was.
Okay, now we'll replace anything that has an I squared. We'll just change the sign.
So negative 10
So it's going to be
Minus 10. No, minus 10.
minus 10,
plus 25.
and then 9 plus 25. The last part is just kind of rewriting it so it's in the proper form.
The negative 10 over 25.
Wait, what's
9 plus 25.
9 plus 25? 34. Oh, and this one's kind of a pain because both of these can be reduced, right? Because negative 10 over 34, I could divide both by 2, so negative 5/17, not a really nice looking answer. Minus 3/17 I. Just a little annoying with that. Last simplifying. Oh, we're good. Last one.
No homework time.
I know.
Why'd you go to negative 5 over 17?
To make it in the form a plus bi, I want to make this part separate from this. So if I want one big fraction, I split it up into two parts. Okay, what do you think the last one, what are we going to multiply by?
1 plus I.
Good. So 1 plus I. Now I have to FOIL on the top. But the numbers are small. They're not, the numbers are smaller than the last one. So we have 2 plus I, sorry, plus 2I plus I, plus I squared. And how about the bottom? You just get 1 minus I squared. Okay, so all the I squareds get replaced with -1. Oh yeah, like just, you mean combining. So I could combine 2I and I to make that 3I, right? Look good? Okay, and then what? 2 in the bottom? So I have 1 plus 3I over 2, so 1/2 plus 3/2 I. Okay, let me take a look. Okay, so that was kind of a lot of information in that.